All right, welcome everybody. Let's do this lesson 23, comparing and solving rational equations. So your first notion is, oh my God, we have fractions, get me out of here. But we have to get over this fear of fractions, okay? So here's a nice little quote for the day. Nothing in life is to be feared, it is only to be understood. So we need to learn to understand these ideas of the fractions and how to solve them. And who said this quote? None other than Marie Curie. Mister, you're mad corny, but okay, that's who said it. So let's begin. Here, to solve these rational equations, there are two techniques that kind of work. Not kind of work, I'm sorry, they work. One of them is to cross multiply. And when are you allowed to cross multiply and how does it work? For example, if I have some a over b equals c over d and a, b, c, d, or whatever you want them to be, all you're really doing is, here you're doing d, like here, d times a, which is here, and it goes like this goes on the left side, and then you have b times c, which goes on to the right side. So what's the idea here? Let's just follow this. Here, we're doing d times a, so this becomes 30 times 5, which is 150, and then you're doing what? This b times c, so this is x times 10, so you could just say that's 10x. And then how do you solve for x? What do? Divide both sides by 10, and here x is equal to 15. Okay, so that's the idea of cross multiply. But when are you allowed to cross multiply? Because I see a lot of people get confused. They say, oh, mister, just cross multiply if you see fractions. So let's just understand, when do you actually do it? So you're only allowed to cross multiply if two rational expressions are equal, right? And everybody remember, take your time, pause the video if you need to copy this down, or right? Okay. So you're only allowed to cross multiply if two rational expressions are equal to each other. And what do we mean by rational expression? Think, if you want to say fraction, okay, but for now we have to get used to the proper terminology. Just think of some a over b. So like, look, if I have something over something, something over something, something over something, that's a rational expression, okay? And here what we're going to do is we're going to be solving equations that have rational expressions, okay? And let's take a look at this. Here, can you cross multiply in the first example, right? Let's look at this. Can you cross multiply? And the answer is yes, because I have, it says, when are you allowed to cross multiply, right? You're allowed to cross multiply if two rational expressions are equal to each other. So if these two rational expressions are equal to each other, you're allowed to cross multiply. So here you have like, this 5x is equal to 30, okay? Here, let's take a look at this example. So here you're allowed to cross multiply. What about this example? See, it's the same thing, but now I have this 1 plus. So here, you are not allowed to cross multiply because you don't have two rational expressions equal to each other, all right? So let's try and go through the lesson. Here, we're gonna have two techniques for today, or two methods, method 1, method 2. And method 1 will be to cross multiply, okay? If possible. And method 2, I'll talk about it right after. So what I want you to do is try and do questions 1 and 2 by yourself using the idea of cross multiply and try and solve the equation. Okay, take your time, pause the video. Don't wait for me to do everything. All right, so here, let's see if you want to see the solution. How do we do it? So here we got to do 15 times 16. Oh God, what's 15 times 16? Is that, that's 240, right? Okay, so 15 times 16 is 240, and 8 times x is here. And then here, how do you get x by itself? You just divide by 8, right? Divide by 8, and here x is equal to 30. Okay, not too bad, right? And then how can you check to see if this actually works? Is 8 over 15 equal to 16 over 30? And the idea is you have to simplify these fractions. So how can you, is this simplified? Yes. Is this simplified? Notice you could divide the top and bottom by 2. And if you divide the top and bottom by 2, you get 8 over 15. So you see how this is equal to 8 over 15. That's if you wanted to check it, okay? Let's move on. Here, how would you solve this problem? Same idea, 50 times 13, what is that? That's 650, right? And then what's negative 5 times x is negative 5x. Then divide both sides by negative 5, negative 5. And now here, x is equal to, what is this? Hold on. Oh, it's 130. Okay, I should have been able to do that. Is negative 130. Okay, so great job. If you want, you could try and continue on, but let's look at the second method in solving this, right? So what's the second method for today? The idea for the second method is make all the denominators the same. So for example, let's take a look at this. What did we do before? We cross multiplied, right? That was method number 1. What's the idea of making the denominators the same? So notice that this is 10 and this is 5. How can I make these two numbers the same? The idea is I want to multiply the top and the bottom of just this side by 2. So notice that once this 2 times 5 is 10, and then this 2 times 3 is 6, now I have this expression. Okay, now I have 6 over 10 is equal to x over 10. And the idea is, over here, and please have this down, the idea is, once all the denominators are equal in a rational equation, so you see, when these two denominators are equal, then the numerators are equal. So once this happens where the denominators are equal, what you're allowed to say is that x is equal to 6. And that's it. Okay? The reason why, let me explain in class. It'll take too much time if I do it in the video. So yeah, if you want, you could have cross multiplied too, but we have to learn both techniques because in the future for this lesson, you're not allowed to always cross multiply. So let's learn this other technique here. Let's take a look at this one. How can I make the denominators the same for this one? Well, here, notice that this has an x minus 2 and this has an x plus 5. So what you want to do is, how do you make these two denominators the same? Notice that if this has x minus 2, what does it need? It needs an x plus 5. And then whatever I do to the bottom, I do to the top, right? So this is x plus 5. And if this has x plus 5, what is it missing? It's missing that x minus 2. So then I just do x minus 2 and x minus 2 on top. And notice, now that the denominators are equal to each other, because look at the denominators. You have x plus 5, x minus 2, x plus 5, x minus 2. What are you allowed to do? You're allowed to cross them out and say the numerators are equal to each other. So x plus 5 times 3 is equal to 4 times x minus 2. And then here you distribute the 3, so you have 3x plus 15 is equal to 4x minus 8. And then you solve for x, okay? So you're allowed to do this as a second technique. You could have also cross multiplied, but we have to learn this technique number 2. Okay, so what I want you to do is try and do technique number 2 with the same equation. So if I have 8 over 15 is equal to 16 over x, the idea is, how can you make all the denominators be the same so we can cross it out? All right, take your time. So notice, if you want to see how it's done, notice this has a 15 and this has an x. This always really helps me when I learned it a long time ago. This idea of sharing is caring. So whatever we multiply to the bottom, we multiply to the top. And what do I mean by this idea of sharing is caring? That, like, notice there's a 15 here and an x here. What is this missing? This is missing an x. So what we do is we multiply top and bottom by x. What is this missing? It's missing that 15, so I multiply the top and the bottom by 15. And now here, what happens, you have 8x over 15x is equal to 16 times 15 is 240 over 15x. And what's the trick? Once the denominators are the same, the numerators are equal. So now I just have 8x equals 240, x is equal to 30. And notice that we get the same answer from here and here. Which way was faster? You're like, oh, mister, when you cross multiply, it's so much easier. But you have to understand, we're not always going to be allowed to cross multiply. So that's how it is, right? We need to learn this other technique as well. What I want you to do is try and solve all these equations by yourself. And we'll go over them in class. I'll see you.